the ability to learn songs has evolved convergently in all these different groups in mammals and in birds. But as you said before, we see very similar brain circuitry. So why do you think that is? Is that, I mean, I don't know if you like this idea of deep homology. Is that because there are only certain kinds of genes and circuits that can be used, and so it's really
That's
just
right.
using the same raw materials, or what?
That's right. So yes, I think deep homology is the right word, which is concordant with the hypothesis we came up called the motor theory of vocal learning origin. That we find in all the vocal learners, including humans, the circuits that control spoken language, the ability to produce the learned sounds, and song and birds, is embedded within a motor pathway circuit. I think a motor learning circuit. And one argument I argue is to get there, that ancient motor learning pathway circuit had a duplication, the whole pathway, which then gave rise to this vocal learning circuit. And then it ended up using mostly the same genes as the surrounding circuit, but some genes had to become specialized to control rapid firing of muscles, to have very tight auditory motor integration for sound processing and motor output that you don't necessarily need if you don't learn how to vocalize. And these, like you're asking, I think there's limited genetic toolkit to do this. To make this direct connection that you and I and others talk about from the cortex to the motor neurons, only a few genes can do that. And so you got to mutate those same genes to make a very robust direct connection that you don't see in the other species that can imitate.